Together, we are floating through the universe on this giant blue ball that we call Earth. We speak different languages, but we communicate as people, as populations. We live in cities together, and we consume our news, we consume our media. We experience the world as ourselves and as the communities that we're in. Session 4, population. We'll introduce the speakers in a moment. Prior to that, the historical trivia questions are getting a little bit easier as we're maybe moving up not only in scale, but also in time. So when was the first global scale archaeology enabled? And think about what the technologies were that were enabling global scale archaeology. And when did we experience and observe a drop in air pollution due to COVID? That's probably an easy one to get on the time. So hold those questions in your mind. We'll answer them after our speakers and before the panel. So please ask your questions at the Q&A. With that, I'd like to introduce our next 3 speakers. Thomas Quatieri, Carlo Ratti, and David Rand, speaking about their various works that map into this scale of the population. Thomas will speak about a framework for biomarkers of COVID-19 based on neuromotor coordination of speech. Carlo will speak about sensible cities. And David Rand will talk about fighting COVID-19 misinformation on social media. With that, I'll turn it over to our first speaker. Thomas, please take it away.
Okay, thank you, Brian. Thank you for the introduction, and thank you for inviting me to participate in this very exciting event. Much appreciated. I'd like to begin with acknowledging our team. Not only the MIT Lincoln Laboratory folks, but also our collaborators from the MIT McGovern Institute, MIT Clinical Research Center, the University Hospital Galway in Ireland, and the Spalding Rehab Hospital here in Cambridge and Boston. This team represents a spectacular suite of different disciplines, but also this team, even more importantly, has a significant dedication and passion for addressing the COVID-19 crisis. So there are 2 objectives of this work. The first, which is sort of synergistic with the goals of this symposium, is that by using audio from mobile devices, we want to detect and monitor COVID-19. And ideally, we'd like to do this in the asymptomatic or pre-symptomatic stages or the recovery stages of the condition. We feel this is where we would have the most dramatic impact. The second goal is that we want to extract features from the audio that reflect physiological and neurological dysfunction that may occur in speech production due to COVID-19. Now, if we could meet these 2 objectives, and I want to stress here at the beginning, we haven't met these objectives. This is more vision than a milestone at this point. But if we could meet these objectives, we would have a system that provides a widespread use in naturalistic environments and also has some clinical relevance. So with this as motivation, what I want to do today is first give you a bit of history into how, into the vocal analysis work that Lincoln has done over time, and how it has led into the work we're doing now with COVID-19. We'll look at the potential impact of COVID-19 on voice. I'll describe our methodology for feature extraction that will lead into some of our very early, very initial results, which will lead into the need for validation for bigger data sets and the web-based app that we're developing in collaboration with MIT McGovern Institute. And finally, I'll end with some challenges and the way forward. So, as I mentioned, Lincoln has been involved in vocal analysis for decades. Okay? But over the last decade, one of our focus points has been on applications of health. We began about a decade ago in looking at vocal analysis for depression. That led into work for the U.S. Army and Navy in detecting and monitoring cognitive fatigue, traumatic brain injury, hypoxia due to altitude, and also the effects of sleep restriction. This work then led into the more recent work that we've been doing in a number of other both non-DoD and DoD application areas, including PTSD, Parkinson's, Alzheimer's, and autism. Now, throughout this entire time period, we did not address respiratory conditions. However, many people did. And in the year 2017, it was an InterSpeech challenge. This is an annual speech conference to detect respiratory diseases, and in particular cold flu detection. So it was this work, together with the work that we did over the years and tools that we developed in vocal analysis and other conditions, that led us into the current application area of COVID-19, and more specifically, to the use of vocal subsystem coordination, which is a methodology that we developed over the years, which gave us success in a variety of conditions. Now, we're not the only ones working in this area at the moment. Since I began working on this in the late spring of this year, there have been many groups that popped up in private industry, universities, and in fact, this Friday at the University of Cambridge, in the UK, there will be a conference dedicated to this topic. So you can see that this is becoming a hotter and hotter topic over time. Now, I like to think of speech production in terms of three fundamental subsystems: respiration, phonation, and articulation. In respiration, the lungs provides the ability to exhale and inhale. When we speak, we exhale, and as we exhale, air flows from the lungs through the trachea into the larynx and causes the vocal folds that sit in the larynx to vibrate. We call this vibration phonation. Now, as the vocal folds vibrate, they excite the vocal tract with little periodic or aperiodic puffs of air. The vocal tract consists of the oral cavity and the nasal cavity, and within these cavities we have lips, tongue, jaw, or velum. These are the articulators of the articulation subsystem. Now, each of these systems by themselves are controlled by muscles that are finely coordinated. For example, in articulation, the lips, the tongue, the jaw, the velum are finely coordinated, phased, and timed. There is coordination in each of these systems, but there's also coordination across these systems as well. For example, we know that the respiration system is coupled to the phonation system. We know phonation is coordinated with articulation. So how does COVID then affect this very complex system? Well, we know that COVID-19 is characterized by widespread inflammation that can affect the physiological function of almost any organ in the body. We've seen this. And more recently, there's growing evidence that it also affects the neuromotor systems as well. So given these observations, we have three primary hypotheses. One is that, and this is probably obvious, that injury can affect each of these three subsystems of speech production. We know there's breathing patterns that change, vocal fold vibration can be injured, movement of articulators can change. But in addition, the second hypothesis is that injury can affect the coordination of these subsystems. And that coordination can be affected both within a subsystem, and I gave you that example of articulation, coordination, but can also be affected across the subsystems. And I gave you two examples of that in the previous slide. The third hypothesis here is that these changes in the systems individually and in the coordination of these systems within and across, these changes may be subtle, especially in asymptomatic and pre-symptomatic and recovery stages of COVID-19. Okay. Now, the goal here, ideally, is to get into these systems, make measurements directly if we could, but that's not what we want to do in developing non-intrusive, simple schemes, like with mobile devices, like smartphones and tablets, for example. Right? We want to be able to use the acoustic signal as a proxy to the measurements that we ideally would want to make internally. As an example of this, what I'm showing here is an example of the measurements that are made of the articulatory system, but using the acoustic signal as the proxy. We derive vocal tract resonances from the acoustic signal. And what I'm showing in this panel of time versus frequency is a spectrogram, and I'm superimposed on the spectrogram of 3 trajectories of the vocal tract resonances, which we, in the speech world, we call the formants. Okay. We look at correlation. We find correlations at different time scale across these different trajectories. We put these correlations into a big matrix, correlation matrix we call it, from which we derive an eigenspectra. I don't have time to talk about the details here and a lot of the theory behind it, but the shape, the morphology of these eigenspectra sort of define the nature of the coordination. That coordination could be under complex or sort of have a reduced complexity. That coordination could have an excessive amount of complexity. I like to use the analogy of a skilled piano player whose fingers are finely coordinated in creating beautiful music. A condition, however, might cause a sort of a reduction in the complexity of these, so they stick together. Or a condition could create a over complexity of the movement, where they're all really independent of each other. So this is the kind of information that we can gather from the eigenspectra. Now, how do we test our hypotheses? Well, we need data. When we first began this in spring, April of last year, we had no data. So we thought, hey, why not use data that's publicly available? We can get it off of YouTube, Instagram, Twitter, and we collected data from a variety of celebrities who had tested positive COVID-19. We also got baselines of them previous to the diagnosis, and we looked at effect sizes. We were able to get 5 cases with reasonable similar backgrounds pre and post COVID. The effect size plot is shown here with respect to the eigenvalue index. We were getting reasonable effect sizes in this case. This is work that was performed by Tanya Tucker, who's a graduate student working in our group. Beyond that, though, we went to another open source data collection. This is a data collection a little more formal than just grabbing stuff off the internet. This is a collection that was done by a startup company, Voca.ai, in collaboration with CMU, Carnegie Melon University. They have a website where you go and donate your voice, and you follow a certain protocol. You recite the alphabet, you count, you recite some vowels. And up to now, there have been primarily control cases with a small number of post-positive COVID cases. There's been no longitudinal data. There's no baseline versus after versus post. So it's control versus post from different populations. We've got from this 17 cases of COVID, over 1,000 control, who performed the entire protocol. Again, in this case, across control versus post, we got reasonable effect sizes. And this is work that's been, that Jim Williamson, who was a technical staff member in our group, has been focusing on. We also did detection with this as well. We looked at a variety of features that represented coordination both within subsystems and across subsystems, and designed a very simple Gaussian mixture classifier, did some cross-validation, and obtained a reasonable AUC of 0.85 in this case. So these were encouraging results, both in terms of effect sizes and detection. But I must say, and I'll stress, far from validated. Okay, we need bigger data. We need more controlled data sets. So toward that goal, we are collaborating with Safra Ghosh and his graduate student Dan Lowe at McGovern Institute to develop a web-based app to be used by anyone in the world. It will be released soon, hopefully within the next month or so. Although it can be used by anyone, anywhere, we are initially focusing our attention on the medical community. And in particular, well, I should say the reason for this is we want to be able to make not only voice measurements, but also physiological measurements as well. We want to match the two. We want to see how well we are consistent with physiological measures. So in particular, we're collaborating with MIT Clinical Research Center, Catherine Ratti, Derek O'Keefe at University Hospital in Galway, and Paolo Bonato here at the Spalding Rehab Center Hospital in Cambridge and Boston. So, and to end, we have seen some promising results on 2 different data sets, and I stress uncontrolled data sets. And this has led us to the need for larger, more controlled data sets of pre and post COVID-19. Ideally, we would like data sets that include and pre-symptomatic recovery stages. Another very important element here in validation is addressing confounders. Recording dependencies. Do the recording conditions change pre and post COVID? Quantity mismatches, we've seen some pretty significant ones. Changes in underlying vocal status from pre to post time recordings. That's another very important one. A person could develop a polyp or a nodule over time, or some other vocal condition that could change this, the meaning and the correctness of our results. Anxiety is a big factor here. If I think I have COVID, if I've been exposed to someone with COVID, anxiety can set in. Anxiety changes voice. We've seen this in our own previous work. Sleep patterns are known to be changing in this COVID-19 era. Okay? And sleep changes voice. So these are all possibilities. These are all possibilities that introduce confounders. Further research for clinical relevance includes matching vocal features with neurophysiological ground truth based from imagery, spirometry as examples. And this is why, as I said in the previous slide, we are coupling in with the medical community and centers that will provide us this kind of ground truth. And finally, a very important component here to future research is understanding how specific are our vocal features, our vocal biomarkers. Are we detecting COVID? Are we detecting some other COVID-like disease, flu, the common cold, some other respiratory condition like bronchitis? This is a very important issue and a very important problem that requires bigger data sets. And finally, it would be of big interest to be able to understand from our vocal features, where is the injury coming from? Is it physiological? Is it because of physiological inflammation? Is it neuromotor dysfunction? Again, these are other questions of specificity that we want to address in the future. So thank you, and that's the end of my talk, and I'll see folks in the Q&A session later.
Good morning, good afternoon, everybody. Thanks, thanks for this. Great pleasure to be here. So what I want to share with you today is some of the work we've been doing in the MIT campus about what has happened since COVID. And I wanted to start this op-ed. This was in the Harvard Business Review a few years ago, and the title the review gave was, "If work is digital, why do we still go to the office?" And what we claim in the article, in the op-ed, is actually still very important. Physical space is still very important. It's still very important to go to the office, even if we can connect from everywhere. And what we tried to do was actually use a lot of data collected over the past few years on the MIT campus. What you see here is actually our campus. You see, MIT like a small city inside the city. You see Boston downtown, Harvard, don't bother, up there. And, the MIT campus is in the United States to be fully covered by Wi-Fi, which means that over the years, we've been seeing a big change in the way we live and work. People used to work, as you see there to the left, and now tend to work more, as you see there, to the right. Well, I need to tell you, what you see to the left is probably the most depressing computer room I've seen, and to the right is a beautiful sunny day, probably not like, during winter time, but it gives you a sense of the same thing we've seen all over the world. We used to work like this, and now we tend to work like this. And that was actually caused by connectivity, by the fact that we can actually connect anywhere and we can, work from anywhere. So then our idea was, because connectivity is changing the way we work, what about using the data from the network to better understand and quantify this? So we started analyzing campus. What you see here, all the M11 AM, you see the bubbles are proportional to how many people are over there. And then if you analyze this, you can find interesting that, for instance, aggregated activity on the campus. You see that, not that well, Monday mornings, in Monday, Tuesday, Wednesday, on the x-axis. Some people get into the campus around 9 a.m. A few people leaving at 5 p.m. You can clearly identify the 9 to 5ers. Most people keep working till very late at night, and even in the middle of the night, there's still a lot of activity on the MIT campus. And the same is true on Monday and Tuesday and Wednesday. On Thursday, not on Friday, activity slips away very quickly, as you see here. And then Saturday or Sunday are almost like 2 normal days. Just remove the 9 to 5 people, and you see still a lot of activity. It's something quite interesting. You see there on Sunday night, you got a little dent. You know, the dent is 9 or 10 p.m. Is, you know, when people say, "Oh my God, tomorrow is Monday again," and you remember all the things you haven't finished before the beginning of the new year. So in data, but you same type of curves you can collect on every square foot, in every room. You know, you can collect different resolutions. What you see here is at the room level. You know, those are kind of occupancy curves. So what you see here is it tells you over time how many people you have in a certain room. Or again, you know, in perspective, you can look at this at even higher resolution, how intensely every square foot is used. And again, you know, this big data is quite a goldmine. It's a goldmine if you're a real estate developer, because it allows you to really see how well you're using a given. It's a goldmine also if you want to understand how a university campus works. And so you can analyze it. There's a few papers. You find them on our website. They're all, you can download all of them. You know, we looked at, as a simple Fourier transform, we look at eigen decomposition. And what you see is really something interesting. This is the map of the MIT campus based on how people, on the activities people carry out. And you know, the same map probably a few decades ago would have been very separated, different colors in different spaces. But now what you're seeing is this kind of overlap of different functions over time, which is something we got to learn very, very well during COVID time. So this is what we have been working on, and we also been applying some of this in the design. You know, this is from our design office, been in design of some buildings, try to apply some of the lessons learned into new office designs. This is one, it's the Agnelli Foundation in Turin, where we actually try to apply some of the learnings you were seeing before into real design office. But, you know, then COVID arrived. And, you know, and then somehow we started seeing a big change. The key change, of course, is that the campus was shut down, but that in turn meant that actually many other interactions change on campus. And actually, again, going back to some of the key questions, the question is, you know, I started with the other article, the op-ed I did in the Harvard Business Review, claiming the physical space was still very important a few years ago, but is this still going to be the case? And, you know, you may question that. That's actually a title from Twitter a few weeks ago, announcing that, a couple of months ago, announcing that employees would be allowed to work from home forever. So is something fundamental? Is there a fundamental shift in the way we work? And so again, in order to try to answer this, look at data from the MIT campus. And after a couple of years of internal MIT IRB, we actually started collecting in December 2019, so before COVID hit, a lot of anonymized data about the network of connections by email on the MIT campus. And you see here some of the data, again, a big data set. You see all the you see to the right, you see all the information about the campus, and the data set we've been collecting about 3,500 people, all anonymized, and we to make sure exact network, but we can build a network for which preserve parameters we're interested in. And you see here some information about the data set is about 3,500 anonymized people's email accounts from 64 research units and 5 people in each randomized group. So again, that we don't know individual communication, but we preserve through the anonymization process, we preserve the key parameters of the network. Now, then we started analyzing this. And as we all know, something happened in the middle. Something happened that, we were collecting the data before COVID, but also after COVID. So after the MIT campus was closed. This is almost like the experiment that you can never do in economics or in sociology. Is when you take one variable and from one day to the next, you disconnect it. And you can look at the impact on that. In this case, we know what happens on campus and how people interact. And so I want to show you just briefly some of the networks we've been collecting. What you see here is before the COVID emergency. What you see here is the network of communication. You see also simple clustering of the different communities. And you see, by the way, you see different schools. You see them here. I'll show you another slide here. By them, engineering, science, all the different, the beautiful parts of our strong MIT community. And then, that is just detected based on modularity, starting from the network of interaction between all of us. And then, they got the COVID emergency, and then from one day to the next, as I was saying, physical space doesn't count anymore. So from one day to the next, the campus is shut down. And actually, the network changes significantly. I'll show you now just some visual changes, but as you see, the way we communicate, this is the same algorithms, but as you see just visually, the data visualization is quite different. And you see actually the clusters becoming stronger. I'll show you numbers in a moment to quantify the first way to look from just using data visualization. You see the same exactly information we saw, the same visualization we saw before, now for the next following COVID. And then basically what we started seeing is really quantify some of these changes, looking at increases in this different communication. We started looking at the beginning at a few sanity checks, looking at how links were changing, looking at how links inside the community, outside the community were changing in a differential way, really analyzing the topology before, in February and in April, before COVID and after COVID. But here I wanted to look at two very important measures that we really focus on. The first one is a measure which is about weak ties. This paper is a paper in sociology. It's a paper by Mark Granovetter, a professor at Stanford. It's a paper from 1973. Many of you probably know it. It's called The Strength of Weak Ties. And well, the idea of Mark Granovetter is actually the weak ties are very, very important in our social networks. Weak ties are where a lot of information goes through. Just to remind you about weak ties and strong ties, if you think about your friends, you see here basically weak ties and strong ties in the two different colors. Think about your network of friends. You got two categories of friends. You got some friends who are also friends of another of your friends. So you basically create a triangle between them. Those are called strong ties. But also you got other ties. They're not weak because you talk to them less. But they're called weak ties because, they're people your other friends don't know. Bridges, as you see on this image, another community. They're bridges to a different set of people. So if you look at this in strong ties and weak ties, you see how they're defined. And what Mark Granovetter found, as I was saying, is that weak ties are very, very important. Hence the title, The Strength of Weak Ties, because usually new information comes out through weak ties. Weak ties connected to a new community, which is where we might be exposed to something we don't yet know. Inside of our closely knit circle of friends, quite often we just keep on repeating to each other the same things. But new information tends to come through those bridges that connect us to a different community. Now, the interesting thing is that weak ties usually form in physical space. Weak ties happen because you're on the MIT campus, you bump into somebody you barely know, or somebody who's not part of your closely knit circle of friends, and then you decide to go and have a coffee, and that's where you might come up with a new idea or, get new information, be exposed to new information. So the first question we ask is, are we losing weak ties? Which usually, as I was saying, relate to our physicality, to the physical. It actually seems that that is the case. And if you look at the number of bridges in the last week of February and the last week of April, by the way, take all of this with a pinch of salt. We're still analyzing the data. We got much more data now, so we're still doing analysis. And we're going to publish this soon as when we're comfortable with the results. But I want to share this with you as work in progress. As this is something like looking at ourselves, at our community, and learn from our community, the MIT community, learn something that might be useful for other organizations and for offices all over the world. So the first result is that it looks like we're losing our weak ties because we are not connecting in physical space, we're just connecting in this digital space. And then the other question was about diversity. We know that physics is a very important function. I actually recently did a Boston Globe about this, is also the office, but also the space of the city. Public space has a very important qualities. Space, we are confronted with digital circles. Online can easily edit our own communities, can remove, not connect with all the people who challenge our edit in physical space. We cannot. That's why it's inevitability, but that's because having more diversity, then that diversity is then the starting point for, again, being exposed to creative. There's a lot of again here the hypothesis is, are we losing diversity? Because we're all working remotely, and it turns out that yes. And by the way, diversity, unexpected in physical space at MIT, and again the first results seem to suggest that we are losing some diversity. So I want to share with you how we can start about ourselves, useful for others, and it seems that the first finding seems to be that physical space will still be needed. And most likely will not be able to all go working from home, like Twitter said, but we need physical space, maintain the strength of our social network. I will stop here. Again, take this with a pinch of salt because it's not the final results. We'll publish it as soon as we're comfortable from a data analytics point of view. I just want to share it with you, and thank you very much for listening.
It's great to be here, and I will take this time to tell you a bit of research that we've been doing on trying to understand COVID misinformation on social media. COVID is not only a actual pandemic, but in parallel with the sort of medical pandemic, there is an infodemic of misinformation that's been going around with all kinds of inaccurate information circulating, a lot of it on social media, which can really undermine efforts to sort of contain the virus and the pandemic. And so what we're trying to understand in this work is why it is that people share misinformation and therefore what we can do about it. So now the most obvious reason that people might share misinformation on social media is just that they're confused and they think the information is true. Everyone's doing their best to share accurate information, but it's complicated and people have low medical knowledge and so on, and so they're just mixed up. And so what we did to try and see the extent to which confusion seemed like a good explanation of the sharing of misinformation is we ran a survey experiment. We recruited about 800 Americans, quota sampled to match the national distribution on age, gender, ethnicity, and geographic region. And we showed them a set of 30 headline cards in Facebook format. Half of them were true. This was our set of true articles, and half of them were false. And then in order to assess the role of confusion, we had two different conditions. Half of the people were assigned to the accuracy condition, where for each headline, they were asked, to the best of your knowledge, is the claim in the above headline accurate? And then the other half of the people were in the sharing condition, where they were asked instead, would you consider sharing the story online? For example, through Facebook or Twitter. So this lets us assess perceived accuracy, and this lets us get a sense of sharing intentions. And now what I'm going to show you is the fraction of headlines that people said that they would share or that they said were accurate as a function of whether they were true or false. And now if the sharing of misinformation is driven by just confusion, then these two conditions should produce similar pattern. When it comes to accuracy, we see that people are on average actually pretty good. They rate the true stories as much more true than the false stories. However, when we ask them about whether they would share the stories online or not, we see a very different pattern where truth has almost no effect on sharing. So people are much more discerning when you ask them to judge accuracy than when you ask about sharing. And in particular, if you look at the false headlines, they're about a 33% more likely to say they would share false headlines than to rate them as true. And so that suggests that there's a good chunk of the sharing of misinformation that is probably not just due to confusion. So if it's not that people are confused, then why is it that people are sort of being not discerning in their sharing of social media content? And our proposal is that they're just distracted. Social media, by design, these platforms are constantly inundating you with all different kinds of information. Most of it's social. You're getting social feedback. You're getting notifications. You're getting all this kind of stuff that is never about accuracy, but it's instead about all of these other, often, like I was saying, social dimensions. And so the proposal is that this context distracts people and focuses their attention away from accuracy and onto other dimensions of the situation. And so if that's true, then you should be able to improve people's sharing discernment, improve the quality of the information that they share by focusing their attention back to the concept of accuracy. And so we wanted to test this in some more experiments. So in a second experiment, we had a control condition that was similar to the sharing condition of the last experiment I told you about, where they just saw the same set of headlines. And for each one, we said, if you saw it on Facebook, how likely would you be to share it? And here I'm going to show you their level of discernment. So this is the difference in the sharing of true headlines minus sharing of false headlines. And so this shows you it's overlapping with 0. They're on average more or less just as likely to share true headlines as false headlines. And so this matches up with what I showed you before. And now in the treatment, it's exactly the same, except at the beginning of the study, before they get into any of the sharing, we start out by just showing them a single headline not related to COVID, and we say, in your opinion, is the above headline accurate? They give their accuracy rating for this single non-COVID headline, then they go on to the main task, and again, they say whether they would share the 30 different headlines. And so the idea here is, when they're making their sharing decisions, the concept of accuracy is more likely to be top of mind because they rated the accuracy of this one other headline beforehand, and so it just kind of activates the concept of accuracy. And what we see is, compared to the control, where people were not very discerning, they're more than 3 times as discerning in the treatment. That is, the difference in sharing of true versus false headlines is 3 times larger. So this very simple nudge substantially increased the extent to which people took accuracy into account when deciding what to share. So this is one approach to nudging accuracy, and then we run those studies in March, and then in April and May we ran a set of follow-up experiments. This was in collaboration with Jigsaw, part of Google's sort of security R&D efforts, where we recruited about 1,000 Americans and tried a bunch of different interventions on them. All different ways to nudge the concept of accuracy. So one thing that we tried was providing digital literacy tips. So this is just, think carefully about the news with these tips, and here you be skeptical, investigate the source, watch for unusual formatting. We think that this is probably not going to actually teach anyone anything they didn't know already, but just seeing that card activates the concept of accuracy. Similarly, we had another condition where we asked them, how important is it to you that you only share articles if they're accurate? Almost everybody responds very important or extremely important, and filling out this survey, again, makes the concept of accuracy top of mind. We found that it also works particularly well if you combine it with information saying, we've asked other people and everybody else also thinks it's really important. And so what we found is that each of these treatments substantially increased sharing discernment. It worked equally well for Democrats and Republicans. It worked equally well for people who were more versus less concerned about COVID. And we found that it worked better for people that engaged in more critical thinking and more COVID news seeking, who therefore probably had more accurate beliefs in the first place, and for people that were older. So together, this is a set of evidence suggesting that nudging people to think about accuracy in a variety of different ways can make them more discerning in their sharing. And so we think that these results are quite promising, but of course, this was all just using sharing intentions in the context of survey experiments, not looking at actual sharing online. But there's reason to believe that these sharing intention results should generalize based on a field experiment we ran. Now, this experiment we ran before COVID happened, and so this was looking at political content rather than COVID content, but it sort of grows out of the same line of work. Where what we did is we created a bunch of Twitter accounts called cooking bots, so it identifies as a bot, but a sort of non-political bot. And then the bots, we sent this direct message, so a private message, again, showing a random non-political, non-COVID related headline, and just asked people how accurate is it. And we sent this message to over 5,000 users who had retweeted links to Breitbart, a sort of prominent misinformation site. Well, let's say a prominent site that produces a lot of misinformation. And we just say, hey, thanks for following me. Can I ask you a favor? I can't tell how accurate this headline is, and I want to find out. Now, almost no one responds to the message, but that's okay. They don't need to respond to the message. As long as they open it and just read the top line, they've effectively been treated in that the concept of accuracy has been activated. And so what we do is we send this message to all these 5,000 people. We randomize the day on which any given user is messaged, and so that allows us to do real causal inference on the effect of receiving the message on their subsequent tweeting. So in particular, we look at all the links that they tweet in the 24 hours after they receive the message, and we compare the news sites that they're sharing for the people that got the message compared to the people that did not yet get the message. And so the way I'm going to visualize the results is I'm going to show you one circle per news source. On the x-axis, you're going to have the trustworthiness rating given to that news source by a set of 8 professional fact checkers. And on the y-axis, I'm going to show you the effect of receiving this think about accuracy message on the fraction of tweets directed at each news source. So positive values means the accuracy nudge tweet increased relative sharing of that source. Negative values means the accuracy nudge tweet decreased the relative sharing of those sites. And the size of each dot is proportional to the number of pre-treatment tweets made to that source in this set of users. So what you can see is that there's this strong positive association where the more trustworthy the fact checkers rated the site to be, the more the increase in sharing as a result of receiving our accuracy prime, and the more untrustworthy the fact checkers said it was, the bigger the decrease was. And in particular, our tweet message decreased the sharing of these prominent sort of hyperpartisan sites that were, shared a lot by this group prior to receiving the message, and it increased the sharing of mainstream sites, and in particular, sort of more left-leaning mainstream sites. So This is evidence that these kinds of accuracy nudges, prompting users just to think about the concept of accuracy, can really be effective in the real world. And the way that social media platforms could easily deploy these kinds of things are while you're in feed and you're just scrolling through your, your Facebook feed or your Twitter feed or whatever, every once in a while they could have a pop-up that says something like, help us inform our algorithms. How accurate do you think this headline is? And then they could either respond that it was accurate or inaccurate. And the idea is, even if the platform threw away the responses, this would be an effective intervention because it would just make the concept of accuracy top of mind to people. We also have a whole other stream of research that I don't have time to talk about today in detail that suggests that the platforms also should not throw away the responses, but that using crowdsourcing is actually can be a very effective way to help the fact-checking of misinformation scale. There's the problem with professional fact-checking is it takes fact-checkers a long time and a lot of effort to sort of determine whether any given claim is true or not, whereas it's easy to just make up garbage claims and put them out there. So there's a big scalability problem, and we've got a lot of work suggesting both with political misinformation and with COVID misinformation that crowdsourcing can actually be quite effective in helping fact-checking scale. Which is all to say that I think that this kind of intervention kills two birds with one stone. It helps nudge users to think about accuracy in general, and it creates useful data that could be used to help inform algorithms that are trying to identify misinformation and either downrank it or label it. So to pull this together, our research suggests that the spread of online health information is driven to a meaningful extent by inattention. And that's because the social media context makes salient all kinds of social factors that are not accuracy. It also gets people really emotionally aroused. And particularly in the context of COVID, there's a lot of fear and concern. And we have research that suggests that sort of emotional arousal makes people less discerning in their beliefs. And so the social media platforms are sort of by design spaces where people are not thinking about, in a sort of calm, cool-headed way, is this true or is it false when they're making their sharing decisions. But that's not, it doesn't have to be that way. There are pretty simple things that you can do to nudge users to think more about accuracy when they're on platform and thereby increase their discernment when they're deciding what to share. And so this kind of nudge approach offers a scalable intervention because it doesn't rely on individual fact checkers keeping up with misinformation. It's just something the platform can do directly to individual users, nudging them in a sort of non-paternalistic way. The centralized authority isn't deciding what's true or what's false. You're just helping people use their own reasoning facilities to identify and not share misinformation. And of course, a major caveat to make here is that misinformation and COVID misinformation is a global phenomenon. We've mostly focused on the US. We've also replicated these results in China, but before it's rolled out, globally, we really need to test the cross-cultural generalizability. These are the two papers that we've produced describing this research, and I want to thank my team on all this work and you guys for listening.
Thank you, Thomas and Carlo and David for your presentations at the population scale. So as we're waiting for our colleagues to go to the panel, I'll share with you the answers to the questions, if you will. So global scale archaeology, when was that really enabled? Not too long ago, but actually going back from some of the first satellite imagery. The Corona satellites were CIA satellites with imagery that was acquired with film. The film then dropped in canisters that were then retrieved. And we're seeing imagery on the left from the Corona satellites in the late 60s era compared to some of the the satellite data now, and this is in Mexico City actually, and looking at the impact of population growth on archaeological sites in Mexico City. So global scale archaeology as enabled by satellite imagery. And then more recently, sort of 2020, NASA satellite data allowing us to see the air pollution drop, not only over the northeastern US, but all over the US and all over the world, as our changing habits have influenced how we commute and how we work. So with that, I will welcome now our panelists. And I believe that we're not going to be joined by Carlo. I think his internet connection was bad. In the context of data sets, Thomas and David, you both mentioned sort of needing data or where you got data. So how important is it for you to have curated data sets and sort of open source access to data? And then how do you then make the data that you're labeling and your results available to other researchers? Is that something you like to do? What are the constraints from doing that? What are those issues around data access and data sharing?
Well, I can take a crack at that first. Well, the web-based app that we're developing with the McGovern Institute will result in a data set that is publicly available if the subjects consent, and that's clearly a goal that we have. We would like to make that data set publicly available. It's important to us to know that we're sharing the data, and it's also important to us to know that other people will share their data, because we are data starved at the moment. As you can see from my presentation, initially we were grabbing data from the internet, and then we're now counting on other people's data collections, and that's actually a plus. But we're finding, even in, let's say, the Voca.ai database, which is an excellent data set, there's a scarcity of COVID-19 cases, and this is a big concern. We need to have more COVID-19 cases to balance the data against controls, to get more validation of our results. So that's, I'm certainly in favor of data sharing, and as I said, the McGovern Institute collaboration will result in a data shared database.
I'm also a big proponent of open data and data sharing. For most of what I'm doing these days on COVID is these survey experiments, like what I talked about in my talk, and we always make all of our data available, anonymized, of course. But we post on the Open Science Framework website all of the data from all of our experiments. And when we do these Twitter experiments, it's a little bit more complicated because of the identity, the sort of confidentiality concerns. So like we can't identify the specific participant, like the specific Twitter users that we contacted in our experiments. But like on the flip side, all of the Twitter data is public. So it's sort of complicated on that front, but I think that open data is extremely important, particularly in this. I think it's true in science in general, and it's particularly true in the case of the the sort of global challenge like COVID.
Along those lines, how does an individual that is potentially a font of data, their own data, how do you engage them? Is it appropriate to engage? There's the privacy concerns, but it's my personal information. I don't necessarily choose to share my medical information. How can I choose in these different research environments to want to share my data? Is it appropriate to do that without compensation? Is it appropriate to know how that's being used? How do we sort of give those guardrails to where people's data is going?
Well, in the case of the McGovern web-based app, there is an option in the consent form. They can choose to share their data with other researchers besides the MIT researchers. Or they can choose not to, right? And or they can choose not. To limit it to simply MIT and not Lincoln Lab, whatever they want to do, they have the choice of doing that. how we engage them to want to do it. Well, I mean, I guess the idea there is to encourage them to believe in the science, right, and to believe that we're doing good things for humanity, and this is a good contribution on their part to donate their data to the studies. But yeah, that's a great question.
Yeah, and in a lot of our stuff, in the survey experiments, the participants are just directly compensated. And I think it's maybe a little bit less sensitive because we in general are not actually getting access to medical data or behavioral data, although that would be great. I think that would be super interesting. And that's where a lot of our sort of field experiments come in, is trying to make that link to like real behavior. And the issue with the field experiments is that, and this is sort of different from medical treatment where everybody, I mean, there you still have like, controls and placebo conditions and stuff like that, but where you don't want people to know exactly what treatment they're in, but they at least know that they're receiving some kind of treatment. But for these field experiments, like our Twitter experiments, it's essential that the people not know that it's an experiment, because the whole point is to see, could this work in a real sort of ecologically valid context? And for this work, we've gotten IRB approval to not get informed consent, because we're only using private, sort of publicly available data from Twitter, and was judged that the risks arising from receiving one sort of accuracy nudge message were negligible, and actually were likely beneficial because it would help people improve what they share. But the sorts of consent and privacy issues are really important things that we think a lot about.
Very good, thank you. So you both mentioned in different ways aspects of the applicability of your work in other languages and or other cultures. And so it's a different question for both of you, and I'll go with Thomas first. But the data that you've explored has been English data, I understand. The mechanisms, the phenomenology that you're looking for, do you expect them to show up in all language patterns or all languages, or do you expect differences significantly?
Well, yes, I agree. The data that we have looked at up to now, the COVID data was all English data. Although some of that data is from different dialects, okay? Now, in the past, we have, in other conditions like depression, Parkinson's, we've worked with German, Spanish, and French. Okay, now, for the most part, we trained and we tested our systems in the same language, using similar kinds of features, coordination-based features. So within the language, that coordination paradigm seemed to still hold. I think coordination is sort of a universal principle. The coordination of articulation, of coordination of vocal subsystems, is sort of a principle that is the guiding principle in speech production. Okay, so that's not going to change across language. Alternatively, if you test in English, train in English, and then test in a different language, that would not, that's an experiment we haven't yet done. Okay, so is there a coordination, some kind of coordination aspect which is specific to a language? I'm not sure, and that's a very interesting question. Can we train in one language and test in another? We know that we can train and test in the same language, but it's not clear that we can go across languages at this point. We haven't done an experiment.
David, so less from the language perspective, but sort of the language of culture, sort of that social bias maybe that shows up in a particular demographic. How does that show up in your work?
Yeah, I think it's a really important point, and it's something that we've thought about in all of our misinformation work, where if the core observation that we have is when asked about accuracy, people tend to be reasonably good, surprisingly good, let's say, at telling truth from falsehood but that ability to discern truth doesn't really translate into their sharing decisions unless you sort of nudge them to think about accuracy. Both of those things may sort of be more or less true across different cultures. That is, the ability to accurately identify information in the first place and the tendency to disregard accuracy while on social media. Our guess is that at least the latter thing, the tendency to disregard accuracy on social media, should be pretty general, because we think that's sort of a result of the design of social media systems. That is, that you're always getting all these kinds of social feedback. And I think that's pretty generally true, but it's important to check. Like I said, we ran in March, after we ran this experiment on that I presented using US subjects, we ran almost exactly the same thing with a set of Chinese subjects. And the results were generally similar, where they were less discerning when they were making sharing decisions and accuracy decisions, and nudging them to think about accuracy, it increased their sharing discernment. And we're gearing up to do a large cross-cultural study where we run using the exact same set of headlines, the same experiments in 10 or 12 different countries around the world to see how much those patterns generalize.
Very good, thank you. So it's a small panel, so I'll ask you one more question that sort of goes to both of you in different ways, and then we'll let you go. As you look at various ways of enabling the technology research, and you need to collaborate with clinicians or researchers that understand the human constraints, and whether they be privacy or access to medical data, we have on MIT's campus, we benefit from having the Clinical Research Center. And Thomas, you had mentioned them explicitly, and they are a co-sponsor of this event. How do they, as a resource, help to foster and enable the types of questions and research that you're both trying to do in different ways?
Well, in particular, the work that we're doing with the MIT Clinical Research Center is very interesting, because we are sort of merging voice collection with a physiological collection. So Kathy Ratti is directing a physiological collection in collaboration with another team here at the laboratory, actually, and we are now bridging those together. And that has two benefits. One is we can match across physiological measurements and speech measurements. Physiological measurements in this case include skin temperature, skin conductance, heart rate, for example. And we can look at the matching and the consistency of those features in terms of COVID-19, which is pretty exciting. Another benefit of this collaboration with the Clinical Research Center is that we can merge these features. You know, I'm not making the claim that voice alone is going to solve the detection problem. Voice could be used for screening. Voice alone could be used for screening. Okay? If you have a limited number of tests available, for example, may help in the selection of who to test, in contrast to a random selection. But that accuracy could improve if you were fusing voice with other modalities. So if you use voice with skin temperatures, skin conductance, heart rate, for example, we might have a broader platform that would allow us to gain more accuracy than we can do from voice alone. So those are two benefits of sort of bridging, bridging the work that we're doing at the clinical center with the work we're doing at Lincoln and MIT Government. I'm not sure if that answers your question, but
that's a great answer. Thank you for that, David. How do you approach sort of the clinical, sort of the human aspects, institutional review boards? How does that work for you?
Yeah, well, for us, I think the review board stuff is a lot simpler because, again, we're not working with medical data in general. But I think that what we do, because I'm a behavioral scientist, and so the behavior aspect is what I really am most focused on. And so we're really excited about collaborating with more clinical people to bring the sort of behavioral element and the clinical element together. Like we have this project on, this is not COVID related, but it's in this general vein where I feel like a lot of healthcare problems are not actually, like the medical part is reasonably well solved, and the real barrier to things improving is a behavioral problem, like getting people to do the thing that would successfully deal with the issue. Like a clear example in the context of COVID is mask wearing. It's this huge behavioral problem that has real medical consequences. And so like a lot of the work that we do is trying to bring insights from behavioral science to bear on these clinical questions to try and, yeah, essentially solve the behavioral barriers to medical success.
Oh, wonderful. It's exciting to hear. I think there's a phenomenal sort of landscape at MIT and the surrounding communities of bringing together the technologists with the clinicians and answering and asking some very interesting and impactful questions. So gentlemen, thank you very much for your presentations and the discussion, and for staffing the panel despite one of your colleagues being internet challenged today. So thank you.